Hey guys, welcome to Skill-Lync. In one of our previous videos, we talked about the different ways in which information is transmitted. In today's video, we'll look into more of such communication types. ISDn, or Integrated Service Digital Network, is a dedicated channel system between 2 points that can transmit both data and voice over a telephonic digital line. A telephonic digital line is different from the ordinary telephone lines from the fact that they're able to carry data and voice. When initially the concept of long-distance communication came into the picture, analog signals were used to send information from one place to another with the help of PSTN, or Public Switched Telephone Network. PSTN could only transmit voice signals. However, with the advancement of technology, these PSTN lines were replaced with ISDn. ISDn signals were also found to have better quality and speed. ISDn channels are classified into 3 types: B channel, D channel, and H channel. B channel, or bearer channel, is defined at the bit rate of 64 kilobits per second. They are used to carry digitized voice, data, and other low data applications. The second type of channel is the D channel, or delta channel. This is defined at a bit rate of 16 or 64 kilobit per second, depending upon the need of the user. The D channel contains all the controlling signals, such as when you connect a call or interrupt a call, etc. The H channel, or hybrid channel, is defined at a data rate of 384 kilobits per second, 1536 kilobit per second, and 1920 kilobit per second. They are used for high data rate applications such as video calls, high-speed data, audio transmission, etc. Next, we have microwave communication. The existence of microwave communication was demonstrated in 1888 by Heinrich Hertz. They gave a frequency range of 1 GHz to 30 GHz. Microwave communication occurs only through line of sight. This means that both the transmitter and receiver should be in the visible range. Since microwaves have high bandwidth, multiple signals can be sent at the same time. At the transmitter end, a number of signals are combined together with the help of a multiplexer. This forms the baseband signal. This signal is modulated with a carrier frequency and further amplified and directed towards the receiving station. If the distance between the transmitting and receiving station is more than 50 kilometers, then the signal is passed to a repeater station. At the repeater station, the signal is up-converted to a higher frequency. This is done so that the signal that is entering and leaving the repeater station do not interfere with each other. At the receiving station, the signal is demodulated and demultiplexed to receive the original information. Next, we have satellite communication. Telstar 1 was the first commercial satellite and was launched in 1962 by Telesat's predecessors at AT&T and Bell Laboratories. The transmission from Earth Station 1, or transmitter, to the satellite is called the uplink, and from the satellite to the receiver, or Earth Station 2, is called the downlink. At Earth Station 1, that is the transmitter, the intermediate frequency, or IF signal, is modulated and converted to radio frequency. This conversion is done to up-convert the signal to a higher frequency so that the size of the antenna can be reduced. The signal, after being converted from IF to RF, is sent through a high-power amplifier to be transmitted to the satellite. The satellite is a transponder. This means, other than reflecting the signal to the desired destination, the frequency of the transmitter signal is also increased. The transponder is an RF to RF converter. At Earth Station 2, or the receiver, the signal is passed through a band-pass filter. The BPF restricts the input noise, which originates at the source, entering the low-noise amplifier. The low-noise amplifier will amplify the signal without degrading its signal-to-noise ratio. The signal is then converted from RF signals to IF signals and then demodulated to retrieve the original information. Finally, we have optical fibers. The term optical fiber was coined by an Indian-American scientist, Narinder Singh Kapani, and he is known as the father of fiber optics. Optic cables have the capability of carrying more information at higher speeds than compared to regular copper cables. To transmit information through optic cables, the information signal is first converted into electric signals. These electrical signals are then converted to light signals by either a light-emitting diode or injection laser diode. After this, the signal is passed through the optical fiber. At the receiver end, the signal is demodulated using an optical detector such as a photodiode. Once the signal is demodulated, it is converted into its original form and the information is received at the destination. The optical fiber is basically a very thin hair-like concentric circular structure which has an inner circle called the core and an outer section called the cladding. The cladding has a refractive index less than the core. The light passing through the core undergoes total internal reflection and travels along with the media. Optical fibers are made of glass or plastic. This provides good electrical isolation in hazardous environments. Well, that's all about the different communication systems.